Welcome to EDU-VALUED Academy, where education is evaluated. Today, I have a class of arithmetic progression. It's a special sequence series. What is a sequence series? Arranging numbers following a particular method. Can you see 1, 4, 9, 16, 25? These are the squares of the consecutive numbers. So this way it is written, the numbers are progressing following a particular method. They're in increasing order, and they are the squares of increasing consecutive numbers. So this is a sequence. 3, 7, 11, 15. These are also in increasing order. So definitely these are also in a sequence series. There is a difference between these two sequences. Here 3, 7, 11, 15. Here the gap or the common difference between two consecutive numbers, 7 minus 3, 4, 11 minus 7, 4, 15 minus 11, 4. If a sequence series follows this way, if the common difference between two consecutive numbers remains constant, then this sequence series is an AP, arithmetic progression. Arithmetic progressions, this is in short AP. Here we have 5 variables: A first term, D common difference, N number of terms, An nth term, it is representing nth term, Sn sum of n terms. These 5 variables are here. We must know well about these 4 concepts. First term, it is represented by A, common difference, D, number of terms, N terms, if it is affix is 1, A1 is represent first term, A2 this is second term, An nth term, and so on. Likewise, Sn is sum of n terms. We will have fun with all these 5 variables: first term, common difference, number of terms, nth term, or 10th term, sum of n terms, or sum of 20th term, like this. Now we have come to know if a sequence series progresses in such a way so that the common difference between two consecutive terms remains constant. What does it mean? If a sequence is progressing in such a way so that the difference between two consecutive terms, like 3 minus 1, this is 4, this is also 4, this is also 4. The difference between two consecutive terms is 4 here. So this is in AP. If I ask anybody, could you find the 100th term of this AP? Yeah, we do. How? See, we just multiply 100 means ki 1 less 99 into the common difference is 4. This is 4, and the first term is added. So here we have 1 less than number of terms into the common difference plus first term will give me that term. That means if I want to find out 100th term, so this is 100 minus 199 into common difference 4 plus the first term. So I am getting minus 1 plus 396. This is 395. How I got this one? Here you see, A is the first term. If the common difference is D, the next term will be A plus D. And the third term, this is your A plus 2D. So this is your first term, this is second term, and this is third term. You notice here, for third term we are multiplying D by 2. For second term we are multiplying D by 1. And accordingly, if I write to a fourth term, so definitely A plus 3D. Likewise, the nth term, if say common term, that is general term n, so definitely I will add the first term with 1 less than the number of term into t. This is your to find nth term. Any term I can find out of an A. With the help of this, if I know first term, common difference and the number of terms, so we can easily find out that number of terms easily. So here, this is a sequence series progressing in this way. Is it an AP? If it is an AP, the common difference must be the same. Let's say this is 8. It can be written in the form 2 root 2 because 8 is 2 into 2 into 2. But 2, this is 2 is out and 1 2 is remaining here. Likewise, this is 3 into 3 into 2. This is 3 root 2 and this is 16 into 2. This is 4 root 2 and this is 25 into 2. This is 5 root 2. This way it is progressing. So difference between these two is 3 root 2 minus 2 root 2 is root 2. Again 4 root 2 minus 3 root 2 is root 2. Again 5 root 2 minus 4 root 2 is your root 2. So the common difference is same. So definitely this sequence series is in A. There's no doubt about this. And we can also find out any term of this AP. This is first, second, third, fourth. If I ask you to find out the 15th term of this AP, so 15th term means we will multiply D with 14 and add the first term. The first term is your 2 root 2. This is 2 root 2 plus, if I want to find the 15th term, so 15 minus 1, that is your 14 into common difference is root 2. This is 14 root 2 and this is your 2 root 2. So this is 16 root 2. So the 15th term is your 16 root 2, or I can write this 256 into 2, 256 16 square into 2, 2, 1, 5, 5, 1, 2. This is the 15th term. This way we can easily find out any terms of an AP. And we have got an idea how to find the number of nth term, 20th term, 15th term if the sequence series is in AP. That's what we have learned today. Number 1, this one. And we have come to know about all this problem, like where this is an AP and we can find out any term of this AP. Likewise, this sequence is 12, 27, 48, 75. Here you see 4 into 4, 3 is 12. So this is 2 root 3, 27. This is 9 into 3, 3 root 3. This is 16 into 3, 4 root 3. So this is the common difference between these two. This consecutive term is your root 3. So definitely this sequence is also an AP. Now we have an identity an, that is nth term, is equal to first term plus 1 less than this number n minus 1 into t. This will give me the nth term. Here is an AP 3, 7, 11, 15, 19. This is progressing in such a way so that the common difference is 4 here also. Let's say this is first term, obviously this is second term, third term, fourth term, fifth term, sixth term, seventh. These are known to us. So fourth term is your 15 and seventh term is your 27. And what I want to say is the difference between the two like A7 minus A4 will be 27 minus 15. If the terms, the value of the terms are given, any two terms are given, then if we take the difference, then definitely here this will give an idea. 7 minus 4, this 7 suffix and this is 4 into D will be 27 minus 15 and this is 3D is equal to, this is 12, so D is 4. You see, we have got D is equal to 4. That means we can find the common difference if two terms are given. Just take the difference and then that is, the formula is how AM minus AN is equal to M minus N into D. If the mth term is given, you put the value, nth term is given, put the value, here M minus N into D, so you can easily find out D. Directly, this will be the D. This way, we have an idea here. Here is the question. Which term of 3, 15, 27, 39 it is progressing is 120 more than its 21st term? This question will be solved with the help of this identity also. There are two ways of solving this problem. I'll tell you. It's very easy to solve if I use this. Let's say nth term is 120 more than 21st term. If nth term is 20 is more than 21st term, that means nth term minus the 21st term will give me the difference, that is 120 is given. Because nth term is 120 more than a 20th term. So here, if I use this identity, this is n minus 21 into D is equal to 120. Here you see, we have got it, n minus 21 into D. This is very clear. Now, here it is clear. D is 15 minus 33. D here is 15 minus 3. This is 12. So you put it here. N minus 21 into 12 is equal to 120. So n minus 21 is equal to 120 upon 12. This is 10. So n is equal to 10 plus 21. This is 31. 31st term is 120 more than its 21st term. If I want to get it, so that is 31st term means 30 into D is 120 plus 3, 38th term is 123 and 30 we have got it 31. So 30 into 4, 123, and this is your 21st term, 20 into 12, 20 into 12, this is 30 into 12, 30 into 12, 12 3 is 360 plus 3, this is your 363. 31st term is 363 because we have 31st term. 31st term is 1 less 31st is your 30 into D is your 4. 30 into 4, 12. 30 into here it is 12. The common difference is 12. 12 into 30. This is 360 plus the first term 363. Likewise, if I find 821, 821 also we can find. 821 means this is 3 plus 20 into 112, 1 to 12, this is 3 plus 240, this is 243. So if I subtract 243 from 363, 243, so this is your 120. So definitely the difference between these two terms is 120. We can easily find this easily with the help of this identity, that is difference between two terms. is the difference of the number into D is equal to their differences. This way we can solve easily this type of problem, whether any term is more or less than any number of terms. Here again we have come to know about two identities. This is my last identity for today. See and try to follow so that you will never have any doubt in arithmetic progression. Here S, I want to take the sum of A plus D, A plus 2D. Simply we are using three terms. We want to take the sum of these three. S is equal to A plus D, A plus 2D. Again, if I reverse it, I will add these two. I want to take sum. This is second term, this is first term, this is third term. S here, just reverse it. A plus 2D. This will be A plus D again. And this A will come here. I am just interchanging this one this way. And this middle one will be as it is. That's what it is. So, if I take the sum of this is 2S, you see. If I take the sum this way, this is 2A plus 2D. Plus this is your 2A plus 2D. This is your also 2A plus 2D. This way, we have 2A plus 2D three times. So we can easily say, 2S is equal to 3 into 2A plus 2D. So S is equal to 3 upon 2A. I can write these two, 3 minus A, 1 into D, as we know this 3 is our number of terms and this is less than 3 minus 1 into D. This way, if we progress like up to A plus A n minus 1 into D, this is the last nth term, and if we take sum of the first term with this one, so this will give me 2A plus n minus 1 into D, and this will be repeated n times. This will be repeated n times, so this will be n into 2A plus n minus 1 into D, and again upon 2S, so S is equal to 3 upon 2, so this is your n upon 2. So Sn we have now, Sn is equal to n upon 2, 2A plus n minus 1 into D. I can write this one n upon 2, A plus n minus 1 into D. This way, if I split 2A into two parts, so this is nothing but the last term or nth term. So I can write this formula n upon 2 A plus L. L representing L is equal to nothing but A plus n minus 1 into D, that is nth term. So these are the identities we have today, and this all for today. Again, of my second part of AP, I will discuss about the problems. Thank you very much.